Let's start with the simulation of single phase full wave rectifier. Simscape, electrical, specialized power system, continuous power GUI. Let's save it. Wave rectifier. Passive elements, RLC load branch, controller. Like this. Let's keep it simple. 10 ohms. Then we have a source. Voltage source. 100 volt, 50 hertz. Then we need a power electronic device. Let's take, there is an option to take full bridge converter, or I can have 4 diodes. Let me take 4 thyristor so that I can control the output voltage as well. Control R to rotate and give it a name T1. You can resize this. You can, let us see what we can do. Properties. So here you have control R for rotate clockwise, control shift R for anti-clockwise. I want to change the color of it. Foreground color, it is black. Background color is white. If I make it background color green, it's look good. Let us double click it. Let's switch this. I'm not interested to measure the current and voltage across, current through and voltage across the switch. So now I have one ready. Control C, Control V, Control C, Control V, Control C. So 4 thyristors are now ready. Let us join. We can join here. Terminal to terminal. Gate I have left because gate we will give a separate gate supply. Now this single phase supply, better if I can have a transformer. Where I will get a transformer? Okay. This is all synchronous machines. Let me just check it out. So we got a transformer here in the passive. So here here, yes, transformer, mutual inductor. So let the transformer be here. I'm not able to connect it here. So it seems like this is not able, we are not able to connect this. Oh, this is not able to connect. Great. So this is not compatible. Let me just check again. Thus, let us take this transformer from here only. Electrical machine, passive elements, variable ratio transformer. Let's take this. So we are able to connect this transformer. Now we need to give a constant source. I can give from signal generator. Okay, here it is not there. Let us take up. Here we can have some source. We want a constant source of n is equal to 1. Let's put it like this. N is equal to 1. Correct. And this load, let us take this load. Good. Here we have the sink. We take the scope. And then we need a measurements, sensor and measurements. Here we have current sensor. Let us take the voltage sensor and just measure the voltage. 1. We would like to measure this voltage, also the voltage over here, also the voltage in the input. So we're going to measure all these voltages. Obviously in scope, we want to see 3 different things. Layout, now I'm going to give a gate pulse also. Source, pulse generator. Okay, 1. What is this inside it? Amplitude is okay. Time period, that will change 0.02. Pulse width 5% for thyristor is okay. Phase delay 0 seconds, that's also fine. Control C, Control V. Give the pulse over here. Next, Control C, Control V. Give a pulse over here. Only difference is that this pulse should be 180 degree out of phase. So we need to make it like 180. divided by 360 star 2 star pi. I can write like this, or I can simply write pi. Only pi would be sufficient. Because we are writing in terms of time, so now this is not the right one. This 360 represents 0.02 seconds. I can write either 0.01 or like this. Same thing will be given to the other side here. Now this voltage source I have to connect. So we just connected all the voltage source. Now I will just give a supply. First we will see the output. In the second we will see the input from the secondary of the transformer. And in the third we will see from the primary of the transformer. Time duration 0.1. Here I put it continuous. Let us see what we are getting. The model contain block that require a discrete solver. Okay, we just convert it to discrete. Let's run it. So after that, double click on it, scope. Oh, great. So here we have the primary and the secondary because the turns ratio is same. So we are getting the primary secondary same, and the output we are getting a full wave rectifier. So what else we can measure from here? Let's keep it in one window. Correct. And let us reduce this so that we can have a zoom 0.04 seconds only. Now we can see it zoomed up. 0.04. Now it is clearly seen. So we have two cycles and two output. Let's change the gate pulse. Instead of 0, let's make it 30 divided by 360 star 0.02. That is, we are giving alpha equals to 30 degree. Copy this, apply the same to the other one. This is 1 and 2, so we just give it to this one. Apply. Here, since we have already given 180 degree phase shift, so let us make it 180 plus 30. Copy this much portion. Over here. So 180. Now the firing will be at 30 degree. Correct. Since I getting the primary voltage is not required, so let us remove this primary voltage. So we are just interested in the this and one of the gate pulse. Okay, so let's see the only the gate pulse. We just give triggering. Gate pulse in the lower. We're getting gate pulse over here, and this is input voltage and output voltage. So let the voltage be RL load. 10 ohms, 1 millihenry. And now let us current diameter. Let us say we're not interested for the gate pulse to see. Gate pulse to see. We just interested for the output voltage, then the output current. Current is over here. Measurements. Here is output measurement, current measurement. Here, remove this and let us join here. And here also here. Now the current is ammeter is ready. So let us see the first output voltage, then output current, then input voltage. Input voltage in the secondary of the transformer, which is same as the primary of the transformer. Now let us run the simulation. We are not getting any major difference in the output voltage. We got a small glitch over here. There is a negative voltage and not so much difference. Let's do one thing. In inductor, increase the value of the inductance. Once we increase the value of the inductance, see the difference we have got. The current is exceeding the value of pi. Pi is 0.01 seconds. It is exceeding the value, and we have a negative voltage. And the beta value is not 180 plus 30 degree. If I like zoom it, horizontal zoom, let us zoom only one cycle. It's taking time. Let me enlarge it. Okay, I'm zooming it for one cycle only. Now you can see it is starting at 30 degree. The current is also starting, but the current is not 0 at 2 pi. The current is still positive. That is why we are getting a negative voltage. And the negative voltage, this is the term beta. The beta is not equal to 30 degree. Beta is less than 30 degree, that is nearly 15 degrees. So that's the difference here. If I increase the value of inductance, one more 0, then let us see the difference here. Now you can see the differences. Apart from that, you will find that the current is continuous. It is not discontinuous. Earlier the current is touching the zero part. Now the current is not touching the zero part. If I will increase this range, like suppose 0.04 to 14 seconds, you can see the current is like wave, and it is starting. Zero is over here, and we are getting a current, continuous current with the ripple over. The ripple current is from 6 ampere to 4 ampere. The maximum is 6 and 4. The ripple is 2 ampere of current is ripple, and we're getting negative voltage also here. So you can change the axis like display. First one is the output voltage, Y limit is minus 45, so let us make it minus 60, and the upper one is, let us say, 115. Apply. Then now it seems okay, minus 60, let us say minus 100. Now we can see this is the middle of the axis and we're getting something 2, and this is the output current, and it is also, it's okay, like the range is okay, so fine. And the third one is okay. So okay, but third one we need to write down that the input voltage. Like that, we have got the simulation ready, correct? And this is the entire simulation for the single phase full load rectifier. Thank you very much.